Hello, welcome to Technical Wednesday with Orifa. Yes, I know it's a Thursday and you're getting this video now, but yeah, I'm not going to bore you with the story of why it is dropping now. So moving on, we are just going to do a little recap on what we spoke about last week in case you are just coming across my video for the first time. So last week we got to understand the functionality of the various networking devices, which moved us a step further from their basic classifications as endpoints, intermediary, and media, as the case may be. We spoke about servers, got to understand that the servers are computers or devices that provide services. They could provide multiple services or dedicated services. We got to understand that the clients in this case are requesters of those services provided by the servers. We spoke about the fact that the role of a server and a client is not static. It can change depending on who is doing what at what point of the communication. So a server can also be a client and vice versa. Spoke about a switch which has multiple ports of interface connecting multiple devices together within a local area network with the limitation of not being able to um, foster communication across or between multiple device networks, which we now spoke about the router. The router is the middleman that connects two networks or multiple networks together, forming the Ethernet as we have it now. So last week we laid a foundation on the fact that these devices on their own do not make a network. It is the connection that fosters communication between them that forms the network that we have and the internet as we see it today. And this brings us to our topic for the day, which is network interfaces with a focus on internet layer 2 protocol. So the image you can see on my screen is a switch and a mini router. You can already tell which is the switch. The switch has multiple ports, and you can see the image 2 has multiple ports, 16, and then the second device is a mini router with um, four LAN connectors and one WAN connector. So the LAN model is local area network, and the one stands for wide area network. As times go on, you get familiar with these terminologies as a network engineer. So you can see that these connectors are known as interfaces or ports, and they connect multiple devices together to foster communication. So networking interfaces, like I said, we have multiple different types. So we have the Ethernet wired connection, we have the Wi-Fi wireless connection, we have the loopback, which is internal communication, that means the device communicating with itself, and then we have the virtual, which is VPN or VM. So let's understand what we are going to be talking about today. Ethernet. The Ethernet is a collection of multiple protocols. So the Ethernet is not a single um, protocol, it's a collection of multiple protocols, and it is classified in the layer 2 of the OSI model and layer 1 in the TCP model, which merge with the physical layer. So in case you are already wondering what is OSI model, what is TCP model, we are going to be talking about this. But just for to lay a foundation, these models are like protocols that help multiple devices from different vendors to communicate together. So the key factor to understand from this slide is the fact that the internet is a standard by IEEE, which stands for the Institute of Electrical and Electronic Engineers. And the standard is called 802.3. The Ethernet standard is called 802.3 standard. It is reliable and fast. It is used in offices, homes, and data centers as well. So here's the visualization of the OSI model. Like I said, the OSI model is a layered model, 7 layers to be precise, and we have that layer 7, the application layer, layer 6, we have the presentation layer, and layer 5, we have the section layer, layer 4, we have the transport, layer 3, we have the network, layer 2 is the Ethernet, which is the guy we are going to be talking about today. So, focus is on internet. So, just like I like to say, the digital space is the human created world, and by so it tends to follow protocols and principles that we humans as well follow. So there was a time we have language barriers. We still have it now, and the internet once had that limitations as well. And by this I mean that only devices from same vendors will communicate. Imagine if you have a HP laptop and a Lenovo laptop. These are two different vendors, and because you're using an HP laptop, you can't send message to a Lenovo laptop. That was a big limitation initially prior to these protocols coming into place. So this is the gap that the Ethernet and other protocols, multiple protocols, have come to bridge. It has come to ensure that communication is carried out regardless of the vendor type you choose to use. So the intercommunication between multiple devices from various vendors. So, like I said, the internet provides a standard that vendors use to ensure devices can connect and initiate communication with one another. Device connection operates at a specific speed called bits per second. So, what this means is that the computers don't understand high level language, which is the language that I am currently using to transmit this information to you. So what the computer understands is binary values of zeros and ones. So everything I see is being transmitted into or encapsulated and de-encapsulated into zeros and ones, as the case may be, for transmission to happen over the internet. So everything you're seeing here is transmitted. You're hearing and receiving at your end. It's being transmitted in zeros and ones. So the transmission speed is measured in bits per second. What this means is that it breaks chunks of bytes into bits. So we have what makes a byte. A byte is 8 bits. So 8 bits makes 1 byte. So yeah, the Ethernet standard, like I said, is not one. It's a collection of multiple standards, and we're going to be looking at the copper standard, and maybe, if time permits, we'll talk about the fiber optic standard as well. So speed, the speed of the Ethernet standard ranges from 10 megabits per second to um, 1 terabyte, or it can be as large as you want. But for now, I think the largest we have for now is terabytes or gigabytes rather per second. We haven't gotten to megabytes per second. We haven't, sorry, gigabytes per second. We haven't gotten to the era of terabytes, but with the speed at which the internet and the digital space is evolving, we soon will be having internet speed at that level. So the 10 megabits per second is called Ethernet, and the standard is 802.3i. I'm not going to be reading all of them out. The 100 megabits per second fast Ethernet, and you can see the Ethernet standard that is represented. We have the 1 gigabit per second, and the name is Gigabyte Ethernet. And we have the 10 gigabits per second, and the name for this is called 10 gigabits per second. So the limitation of the copper cable is the maximum length that can be used for transmission is 100-meter length, and this is a very big limitation, and this was the gap that the fiber optic cable come to address. Yes, so UTP. UTP stands for unshaded twisted pair. UTP consists of 4 pair twisted color-coded wires, as you can see from this image. So we have the green and white, the blue and white, the orange and white, the brown and white. Please note that nothing in networking most times are random. Everything has a significance either to the network or to the total communication of devices. And as you can see, the twisting of these cables help reduce electromagnetic interference during transmission. Now, to buttress more on this, the most common type of twisted pair cables used in local area network are straight through cables and copper crossover cables. So what differentiates this UTP wiring is a standard that is applied at both ends. So this image is gotten from the internet. So you can see that the twisted cables, like I said, orange and white, green, blue, brown. Those are the four colors that are here. So you can see we have standard T568A standard and T568B standard. What differentiates these guys? If you look at it closely, you see that the only difference between standard A and standard B is between pin 1 and 2 and pin 3 and 6. So pin 1 and 2 for standard A is white, green for pin 2, and then pin 3 is orange, white, and pin 6 is orange. But on standard B, we have orange, white for pin 1, and we have um we have we have yes. So this is a visualization of how the communication flows between these cable connectors. So if a PC is connected to a switch, this had been addressed, but then we'll just do a little recap, and this is necessary for network engineers to understand, because you might say, oh, I'm not flipping cables, but there are cases where you will be asked to either crimp the cable, or you find yourself in a situation where your Ethernet cable is not functioning well and you want to troubleshoot. So it's necessary for you to know the usage of these various cable type and when to use them on your network. So to, to connect a PC and a switch, you need a straight through cable. And what makes a straight through cable is that on pins 1 and pin 2, the PC is transmitting, and then on pins 1 and pin 2, the switch is receiving. And then on pins 3 and 6, the PC is receiving, and on pin 3 and 6, the switch is transmitting. So this is similar to a router. If a router should take the place of this PC, the router also transmits using pins 1 and 2 and receives using pin 3 and 6. But you have to understand that this is for straight through cables. Through cables are used to connect similar devices together. So just the switch is different and the router is different, so the straight through cable works. And we can see the transmission pin is 1 and 2 and the receiving pin is 3 and 6. This is foster full duplex. Full duplex is allowing both devices to send and receive um, data or traffic at the same time. So the crossover cable comes in play when you are connecting similar devices together. Think, for instance, we have two switches as shown in this image over here. You can see that if we have this switch here and this switch here and we have the straight through cables, there will be collision on the network, because the switch at the other end and the switch at the right hand side is both receiving using pins 1 and 2 and vice versa. So hence why we had to do the crossover connection, where one at the end of one it's receiving using 3 and 6 and transmitting using 3 and 6 and receiving using 1 and 2 and transmitting, and at the other end the other switch is transmitting using 1 and 2 and receiving using 3 and 6. So this is properly explained in the standards that we see here. So for a straight through cable, you can choose to use either of the Ethernet standard at both end of the cable connector, and then the RJ45 connector. But for a crossover cable, you see that the only thing that changed between these two standards are pins 1 and 2, 3 and 6. The rest are the same. So for Ethernet connector standard 568B, you see we have orange, white, and orange on pin 1, and we have green, white, and green on pin 3 and 6. And then on the standard A, we have green, white pins 1, and then green pin 2. Then on pin 3, we have orange, white, and orange on pin 6. This is just like an interchanging of what the flow, the connection is. And when you want to connect a crossover cable, you have to use both standards. So crossover cable uses both standard. Straight through cable just uses one standard. Okay, we have come to the end of today's video. Thank you very much for speaking with me. Next week we're going to be visualizing this using packet tracer and understand the Eternal Protocol more in depth. So, on the next week, bye for